probably want to plan their loss adjusting activities. And as a broker, we're keen to understand the losses both to insurers and also the market as a whole. From an insurer's perspective, at this point, they'd be looking to claim on their reinsurance. So we need to understand after an event exactly what's going on, and again, geocoding helps us do that. So I'll just get the next slide.
Sure, I'm going there. Just a quick question for you, Nigel. For the Australian bushfire, what kind of geocoding are you talking for such situations?
Well, it's address level geocoding. So it's effectively the centroid of every individual building.
Okay.
I think, yeah, in other countries it would be called rooftop.
Ah, okay. Thank you very much.
Yeah, there are different terms in different markets, I notice.
While we're waiting for the next slide, I'll just mention that Australia does have one of the most accurate building level data sets anywhere in the world, so it makes for very accurate geocoding.
Slide between Australia and the UK, and maybe Germany as well, they have very high resolution geocoding. So I wanted to just briefly touch on a part of Willis that some people may have heard of, which is the research network. Which is a unique part of Willis where we join it's a public and private research forum, and it's where we engage with over 50 academic institutions. And the reason we have this is, for one of the points I made earlier, we need to understand not just what happens under normal conditions, but we need to further our knowledge of extremes. That could be extremes of climate, things like why in one year do we get a certain number of hurricanes and then hardly any the next year. We call that clustering. It can also be climate change. So as we've moved into the next slide, you can see that the research network is interested in modeling climate, and we obviously need to understand how that impacts our risk assessment activities. So what you're seeing in the globe on the left is the world kind of split into cells. We call these global climate models, and we can model everything that happens within that cell. So you need supercomputers to do this. I believe